Let's solve problem 1. Luca is making lemonade to sell at a school fundraiser. His recipe requires 4 times as much water as sugar and twice as much sugar as lemon juice. He uses 3 cups of lemon juice. How many cups of water does he need? So, in order to solve problem, we can set up ratios. So it says 4 times as much water as sugar is needed. So we can say water to sugar is 4 to 1, and twice as much sugar as lemon juice. So sugar to lemon is 2 to 1. In order to write all as one ratio, so we can set it up like this, and then we will multiply the first by 2. So we will then write 4.2 dot 1, or we can write it like 8 1. And now we have to answer that he uses 3 cups of lemon juice. How many cups of water does he need? So since he is using 3 cups of lemon juice, so we can simply multiply all of these numbers with 3, and we will get then 24, 6 and 3. So then the answer that we have is 24, and that is E. Problem 2 states 4 friends do yard work for their neighbors over the weekend, earning this much amount respectively. They decide to split their earnings equally among themselves. In total, how much money will the friend who earned $40 give to the others? So to solve this problem, all we have to do is just take the average of their earnings and then subtract the average from the $40, so which was earned by one of their friends. So what we can do is first we calculate the average or mean. So we say average is equal to and now if I take the difference, so that would be then 42 minus 25, and it is 15. So the answer is C. Let's look at problem 3, where Carrie has a rectangular garden that measures 6 feet by 8 feet. She plants the entire garden with strawberry plants. Carrie is able to plant 4 strawberry plants per square foot, and she harvests an average of 10 strawberries per plant. How many strawberries can she expect to harvest? So, first we will see that what's the total area for this rectangular garden. So that is 6 by 8 feet, and he is able to plant 4 strawberry plants per square foot. So we then will have we can set it up like this, like strawberries harvest equal to total area multiplied by plants per square foot, and then multiplied by strawberries per plant. And now if we see the total area is 48, and we have 4 plants per square foot, and then there are 10 plants. So if we multiply, we will get then 48 multiplied by 40, and if we solve this, we will then get 19, 20. So the answer is D for this problem. So let's solve problem 4, where we are given 3 hexagons of these shapes, and it says suppose the pattern continues so that each successive hexagon contains one more band of dots. How many dots are in the next hexagon? So if we see in the first hexagon we have one dot. In the second one we have 3 layers, and the first layer has 2 dots, the next has 3, and the next one then has 2 dots. So I'm talking about these dots. In the next layer, in the third one, the first one has 3, then 4, 5, 4, and 3. 3, 4, 5, 4, and 3. So if we take the next hexagon, that would be hexagon 4, so then it would be 4, 5, 6, 7, and then we will have 6, 5, and 4. And the total number of dots will be simply 4 plus 5 plus 6. And similarly, if we add, so we will then get 9, 15, 22, 28, and then 37. So the answer should be then B for this problem. Okay, let's look at problem 5, where 3/4 of a pitcher is filled with pineapple juice. The pitcher is emptied by pouring an equal amount of juice into each of 5 cups. What percent of the total capacity of the pitcher did each cup receive? So we are going to find percent cup receive. So that would be equal to 3/4 of pitcher divided by 5 cups and then multiply by 100. So we can just simplify it. And now if we solve, we will then get 15%. So the answer is then C for this problem. So let's look at problem 6, where Aaron, Darren, Karin, Marine, and Sharon rode on a small train that has 5 cars that seat one person each. Marine sat in the last car, Aaron sat directly behind Sharon, and then there is another condition and another condition, and we have to answer who sat in the middle car. So to solve this problem, we can make a block diagram and then assign each person to one of the blocks. So let's say that each block represents a seat, and this is the back, and this is the front. So we can say Marine is sitting in the last car, then Aaron sat directly behind Sharon. So it means that Aaron and Sharon, they will be in this position. Now another condition is Darren sat in front of the cars. So if Darren is sitting in front of Aaron, so it means that Aaron and Sharon, they should be either here or they should be here, and then Darren can go in this spot or in this spot. So however, it says that at least one person sat between Karin and Darren. So then what we can do in this problem, then we have to set now Darren here. That would ensure that she is in front of Aaron, and then we can say Aaron and Shireen here, and then Karim is here. So if we set it up like this, then the answer for this question, it becomes A. So Aaron is the one who is in the middle car. Let's solve problem 7, where um, it says how many integers between 2020 and 2400 have 4 distinct digits arranged in increasing order. And an example is given here. So to solve this problem, we can see that we are given the range between 2020 and 2400. So there are a couple of observations that we need to make. The first digit, it must stay as it is. We cannot change it, since the first digit in the other or in the higher range is also the same. The second, it should be 3 in order to fulfill this condition in the increasing order, and it cannot be 4, because then we will be out of this range that is given. So now we have to find out that how many combinations are possible for the last two numbers, so, or the last two digits. So we have 2 here already, and this number is 3. So it means that this number that will be coming in this place, that can be 4, 5, 6, 7, 8, or 9. And as per this condition, like, they are 4 distinct digits and in the increasing order. That means that the last digit, it should be different than the digits that will come or will take the place for the third digit. So how we can set it up? Then we can say that since these digits are 6 and we are having now 2 places, so let's say that this is our third place, this is fourth place. So for the third place we have 6 options, and for the fourth place then we will have 5 options, because the digits cannot repeat. And we also need to ensure that the digits are in the increasing order, so that's why we will then divide it by 2, and then the answer that we will get, that will be 15 for this problem. So the C is the answer for this question. So let's look at problem 8, where Ricardo has 20 coins, some of which are pennies and the rest of which are nickels. He has at least 1 penny and at least 1 nickel. What is the difference in cents between the greatest possible and least possible amounts of penny that Ricardo can have? So the total coins that we have, they are 20, and some of which are pennies and others are nickels. Okay, so we can set it up like this, like greatest amount and minus the least amount that is possible. So if we see the greatest amount that is possible, that is simply 2019 multiplied by 5 plus 1 multiplied by 1 and minus 2019 multiplied by 1 plus 5 multiplied by 1. So just to explain, here these are the maximum nickels and they will maximize the price or the amount, and here is 1 penny only. And again, to have the least amount, then there should be 2019 pennies and 1 nickel. So now we can solve this problem just by rearranging. And now if we solve this, so we will get then 8076 minus 4. So then it is 8072 should be the answer. So it is C. Let's solve problem 9, where a birthday cake in the form of 4 by 4 by inch cube is given and shown here. The cake has icing on the top and the 4 side faces and no icing on the bottom. Suppose the cake is cut into 64 smaller cubes, each measuring 1 by 1 by 1 inch, as shown here. How many small pieces will have icing on exactly 2 sides? So this is the most important thing that we need to keep in mind, that we have to tell exactly 2 sides. So this problem is simple. What we can do, we can simply count the number of cubes, but we need to make sure like they should have icing on the 2 sides only. So if I see 1, 2, 3, and similarly then I will have 1, 2, 3. They will have these 6 cubes, and similarly I can have 1, 2, 3, and 3 then will be on the last edge or the hidden edge that is not being showed here. That's in the into the plane of this iPad. So anyway, so from here I can then have 6 and 6, 12. Plus I will have 1, 2, 3, 4. So I will have then 4 more cubes. And I will also have this and these. So 4 from here. So the total cubes that I will have with 2 faces having icing, they are 20 in total. So the answer is D for this problem. So let's look at problem 10 that states Zara has a collection of 4 marbles and a guy, a bumblebee, a stelly, and a tiger. She wants to display them in a row on a shelf but doesn't want to put the stelly and the tiger next to one another. In how many ways can she do this? There are multiple ways to solve this problem. One of the more or simpler way is just to simply apply the George Harry Yuga theorem. So as per that theorem, we can find the number of ways that we can arrange A distinct objects when B objects are away from each other. So the theorem, it is named as GEOR, George Uga Harry Uga theorem, and so the number of ways is equal to A minus B factorial, A minus B plus 1 factorial divided by A minus 2B plus 1 factorial. So here A, it represents the distinct objects. So we have 4 marbles, so there are 4 distinct objects, and b is basically how many objects are not next to each other. So then I can simply apply it. 4 minus 2 factorial, 4 minus 2 plus 1 factorial, divide by 4 minus 2 dot 2 plus 1 factorial. So if we solve, we get then 2 factorial, we get then 3 factorial, and divide by 1 factorial. And then the answer, it becomes 2 multiplied by 1 multiplied by 3 multiplied by 2 multiplied by 1, and that is then 12. So 12 is the answer for this question.